Welcome to Accelerate Science Now, where we sit down with innovators shaping policy, research, and industry to ask one big question. How do we make science move faster and work better for everyone? In this episode, I sit down with Edward Shenderovich, co-founder and CEO of Roebling, to explore why so many scientific breakthroughs struggle to scale. We talk about the often overlooked gap between discovery and manufacturing and why scientists need to think about process, infrastructure, and cost from day one. Edward shares how Roebling is using AI and integrated modeling to help researchers design better factories and turn scale from a bottleneck into a competitive advantage. Enjoy the show. Today's guest is Edward Shenderovich, the co-founder and CEO of Roebling, a company building modern tools for planning and developing industrial infrastructure across biomanufacturing, energy, and other process-heavy industries. Before Roebling, Edward founded and led multiple technology and investment companies, including Nodal and Kite Ventures, and has built and scaled businesses across software, marketplaces, and infrastructure. Through his work, Edward has developed a deep perspective on why so many breakthroughs stall at scale and how better infrastructure and design can help scientific ideas reach the real world. So, Edward, thank you so much for being with us today.
Thank you for having me.
Yeah, of course. So many of our past guests have had careers that were entirely really focused on science and technology. And so I often start by asking, what inspired them to pursue a career completely in science. But in your case, you've been so focused on business throughout your whole career has been kind of the intertwining link there. So I would love to know, what inspired you to shift and focus a bit more on science when you founded Synonym Bio, the company that is now Roebling?
I just spent many years working in software, built several successful software companies, built an investment company which funded many businesses in software and marketplaces and different online platforms. And then I really wanted to do something in the real world. And with my then partner Amol Sarva, we founded Notel, which very quickly became one of the leading flex office businesses. It was during the time when WeWork was growing at phenomenal rates, and we very quickly became the second largest player in the space. But we were focused specifically on the enterprise customer. It wasn't a co-working business. It was a business of just changing the way people access and secure office. And we had several interesting insights as to how that market should be structured and should operate. And Notel is still functioning. It's you can go to the website; it's there. We're just not managing the company. So as it's owned by a company called Newmark, which was our partner for years, a large real estate and finance business. So we when we left Notel, when I left Notel, I spent a few months thinking about what I want to do next, and I was I mean I was always a bit geeky and read a lot of science fiction when I was a child, and I I think I was always fascinated with hard scientific problems, and I started looking at how science is tackling climate, and one of the questions was that one of the questions that is on the mind of climate scientists is our energy usage. And we are going through this energy transition or energy addition, really, because we're now, especially with the AI boom, we're adding more and more energy to the grid. Um, and in parallel to that, there was what you could call the materials transition, where we're moving from fossil carbon to biogenic carbon. And that move ultimately is inevitable. It will take a long time, but in order to do that, we need to build complete different infrastructure. And I started talking to scientists that are working on really hard problems in synthetic biology, that they're working in labs and trying to design organisms that would produce valuable materials. And what I realized is that they're focused on problems of biology and sometimes chemistry, and not really looking at the problems of physics or finance, of how do you actually build that infrastructure and how do you finance it? How do you and how do you bring these design for manufacturing principles into bench scale research? So we started sitting in with the idea that we would build biomanufacturing infrastructure for companies that are working in labs and will need a lot of capacity to produce. And we first, because my co-founder Joshua and I both come from the digital world, we first built several digital platforms. We built a platform called Capacitor, which pulled together all existing biomanufacturing capacity, and we built a directory and then a marketplace for securing capacity. We then built a platform called Scalar for techno-economic analysis to understand what are the parameters for a company to produce profitably at scale. So we brought in some some of our business mindset and maybe more financial thinking into the biological design process. How do you optimize for success? How do you optimize ultimately for bringing these products to market, making sure that you are producing profitably at scale? So uh, we uh, we got some notoriety through these digital tools, and ultimately the goal was to build factories. We partnered with a company called Premiant, which is a large corn wet miller, actually a large biomanufacturing company in the Midwest, and secured funding from Department of Commerce and started building a factory, which is uh, which will be located in Decatur, Illinois, at one of Premium's sites, and it will be like a really forward-thinking biomanufacturing facility, the only facility of its kind in the U.S.
Wow.
And and um, through all of this work, we we realized that there's a we need to bring this idea of design for manufacturing not only to companies that are doing research in biology, but we can also expand that across a spectrum of different industries, and that ultimately gave birth to Roebling.
Got it. Yeah. And so I think one thing that you brought up that's interesting is that, people who are focusing on these really difficult scientific problems are, thinking about the problem itself, but not necessarily how to scale that. When do you think, like at what point should manufacturing be something that the scientists are thinking about? Like when is it too early for them to be thinking about that versus when is it too late?
I think that they need to start thinking about it at the very start of uh, of their thinking about what they want to make.
Mm,
So if they're
wow.
if you're thinking about what you want to make, you need to start thinking about how you will make it.
Hmm.
What will the process be? And as I think about the impact that Roebling can make on R&D, how we can actually enable R&D teams, what I get back to is like, why aren't engineers involved in these processes early on? And I think it's just too expensive. I
Mm.
think that it has been too expensive for scientists to get engineers engaged in early stages, understand more about processes and manufacturing. And it's like there's a lot of information that needs to be processed, a lot of hard simulation. You need to have lots of inputs that you may not have. And I think what we've done in Roebling or with Roebling is that we've really democratized that. We're uh, making simulations significantly faster, significantly cheaper, and delivering a greater level of fidelity than someone would using Excel or using siloed simulation tools. Uh, so having this integrated model, like a single source of truth that scientists and engineers and ultimately manufacturers can look at and really see the whole process from lab scale to commercial scale is very powerful. And if you can see that from the onset of your research, you can very quickly understand whether the project you're working on will work financially or will not.
Yeah, it makes sense that it would be very expensive to get engineers involved at the start, but it also, on the other hand, if you do a ton of work and then find out that it, can't be brought to market, won't be able to be engineered, that's very expensive too. So it seems like a real game changer to be able to bring that in from the start.
I think that I think it's very important to be able to say no early on.
Mhm.
If you're running if you're running an R&D team, you're always budget constrained, and you really need to understand what to focus on, what pathways would actually work. You are ultimately trying to get a product to market. If you're running a science lab, maybe you can just do pure science. If you're running something in a corporate environment, whether it's a startup or a larger company, you are budget constrained, and you want to optimize the right usage of that capital and optimize it for success. So if you're able to cut off branches of your research that will not yield fruit, you're actually optimizing for success of things that may become successful.
Right. And how would you say that infrastructure constraints maybe determine what kind of science gets pursued in the first place?
Um, I think that I guess science is a separate discipline from engineering, separate discipline from manufacturing, certainly separate discipline from finance. There is like there is science that is being done purely for the sake of science, and sometimes scientists can be working for decades with on very hard problems in physics. I mean, like, there are lots of physicists that are working on string theory, but it's theoretical, and
Hmm.
there are really no practical applications. But if you want your scientific research to ultimately lead to practical applications, if you want to see your science like in applied to real life, it ultimately um, needs to be implemented in manufacturing, whether it's whether it's like biomanufacturing, where you're a lab scientist and you're working on new bioplastics, or you may be working on replacements for polyurethane or replacements for some other products of animal agriculture. You're developing a new fertilizer that will be biological and will be better for will be will produce higher yields, or will ultimately result in higher yields. Or maybe you're working on semiconductor research. Ultimately, you know that these products will need to be produced, and
Hmm.
if you want your product, your science to end up in production, you need to understand how that production process will be engineered, and how that capacity will be built. So um, with biomanufacturing, we're being told by the market, by company CEOs or CSOs, that there's not enough capacity in the world for all the needs of biomanufacturing companies that have been funded, or all the research that has been funded on the corporate level, and that we need like 100 or 1,000 times more capacity than exists, and we need it now. And it turned out simply not to be true. There is capacity out there. There's a lot of
Ah,
capacity that has been built. It's just you can't that capacity is not totally fungible. So one biomanufacturing facility is different from another. There are different pieces of equipment, different unit operations. Um, different sizing of equipment, which is also important because different biological processes have different yields, and in your downstream processing equipment after your fermentation uh, is uh, is not sized for your specific process. So while there's a lot of capacity out there, there may not be capacity specifically for each company, or there's very little capacity for each company because the processes are unique.
Interesting. And so does Roebling help to try to like puzzle piece that together, or how do you solve for that problem?
Um, I think that so we solved for that problem with capacitor, where we provided matching algorithms, and we at Synonym we had a match program where we could match the needs of biomanufacturing of companies that are working on strains and need to produce product with companies that actually have capacity. And uh, I mean, we can leverage that data in Roebling to understand what unit operations are out there, to understand how to best model processes that would be viable for manufacturing. So it's all ultimately with AI, all boils down to data. You need to
Hmm.
have the right modeling, but it's the data on which you train, and how you access that data, and how the data is leveraged in training the algorithms.
Yeah. And
So
so on that note, I mean, so it makes sense to me that, or scientists, whoever can come to you and say, this is what we're trying to make. These are the bottlenecks we're facing. Where do you get the data on like who to match them with? Like what is available out there?
that data is something that we've gathered
Mhm.
from the market. That actually is not a lot of data.
Really?
Um,
Okay.
like there are several hundred facilities around the world,
Hmm.
and so it takes time to talk to all of them, but it's possible. It's just a question of time and resources that you would put into that.
Right.
But
Makes sense that an individual company might not be able to find all 100 of those and figure it
yeah,
out. But yeah.
yeah,
Mhm.
that actually something is something that I learned with my experience building Notel. When a company is trying to get an office, they generally would talk to a broker, would talk to a landlord, but in their case, they will sign an office lease for 3 years or 5 years or 10, whatever the number is, and then they're out of the market. And the people that are selling them that office are always in the market. So the information is always on, like the information arbitrage is always on the side of the provider. So the provider is always getting a better deal at the moment when they're getting that deal. The market may change and the deal may seem worse, but when they're signing a lease, when a company signs a lease, uh, their position is less favorable than the position of someone who's actually providing that service. Uh,
Interesting.
so there's value to being like a customer advocate in this case, and this has been the case with what we're doing with Hotel, and it was equally the case with what we're doing with Synonym, and ultimately will continue to be the case with Roebling. Like we are in the business for our customers, and we want to deliver a product that enables them to do things that they were not able to do before. Like
Yeah.
sometimes things that they didn't think that were even possible. Like as I mentioned, bringing in engineers earlier into the scientific discovery process, enabling R&D teams, like helping companies understand what their minimum viable factory is,
Yeah, really
helping them understand like.
democratizing that information, as you had said. Do you think you could give a specific example? And I know that Roebling is brand new, but maybe with Synonym Bio, of a product that you were able to help actually, get into the world based on your Synonym Bio's help.
So we we worked with we launched this uh, we launched this tool called Scalar, which is really the precursor to Roebling. was the first version of a tool that provided techno-economic analysis, and we had thousands of companies use the platform. Thousands of companies were able to understand the techno-economics of their production, and we enabled many of these companies to uh, make the right steps in their research process, and make the right choices in their manufacturing. Uh, there were companies, and I won't name names, but like there was a company in that was working in colorants. That was one of our customers. They needed to understand the techno-economics of their process for making color purple, and they really were focused on making a certain color, and it was a very complicated process. And as a result, they said, well, that's it's super interesting that all the data you're showing us tells us that it's difficult to produce that color, so we'll focus on something else. And their economics have changed completely, just because we help them understand that there are extra steps uh, in making what they want to make, like
In
in
creating the color purple.
extra
Wow.
process steps. So
Fascinating.
there's some things that are lower hanging fruit that scientists often don't think about, and because they're focused on getting to they set a goal of getting to a certain point, like they want to get to from A to B, and but maybe you actually need to get to some B1 first, and maybe there's not a single B that you want to get to. Maybe there's like a maybe it's a number of variables, some array of variables that you can get to, and some are closer to you than the others.
Right. Helping people see things in a different light. I think a lot of what you're describing has been what many people call the valley of death when going between from research to commercialization. And you've described a lot of different problems that can come up. Do you think you've seen, in your work, maybe like one or two that you think are the most common bottlenecks from going from research to commercialization?
I think it's if I were to point to one thing in certainly in biomanufacturing, it's process development. So scientists generally, scientists that are working in biomanufacturing are generally biologists, and they're focused on biology. They want to make sure that the organism that they're designing performs in the way that that they've envisioned. Uh, then they start working on chemistry, on the media that would optimize the performance of that organism, and then they start thinking of physics, of what is the actual what are the actual unit operations? What happens in the pipes when that fermentation broth goes from my fermentation tank to the centrifuge, and how should that centrifuge be uh, structured, and then how what are the unit operations following that? Like, what type of filtration am I doing? When you start thinking about these things earlier in the process, you may make choices in your biology which are optimized for production. So instead of trying to bring biology into a production, like instead of trying to design a very expensive production process, maybe it's easier to do things biologically, like certain small tweaks that would help you design those organisms for a process that's already standardized, which would be less expensive. So it's almost painful to see uh, many scientists, many startups think that they're discovering something that's completely unique, something that's so unique that you will need to build a completely different factory. or like you will need a completely different production process. Instead of like thinking about these multi-$100 million factories that ultimately need to be built, and then instead of redesigning those for your production process, actually think of what could I do in silico, or what type of bench research do I need to do? How do I train my organisms to actually perform better in the production process that would be cost optimized? And this is an example from synthetic biology and biomanufacturing, but you can draw the same parallels in chemical production, with whether it's specialty chemicals or bulk, in like in critical minerals. How do I actually optimize the process for the future for future production? So start with how much will it actually cost for you to produce. Like because if you start with what you want the features to be, you end up with something that's likely unaffordable.
Mhm.
If you think about building a house, like I would love to have a house that has uh, I don't know, a 50-yard swimming pool, or I would love to have a tennis court or a basketball court, and I wanted to have 6 bedrooms or something like that,
Mhm.
um, and you end up with all these wishes, but then and it's all possible, but then the budget will be different from the budget you can actually afford. So you ultimately should start with like with feasibility. What is
Right.
what is affordable? What is feasible? Um, and then think of like where do I actually what choices do I make? Is that swimming pool really necessary? Is that basketball really necessary? Do I really need 6 bedrooms, or can I survive with 3? So um, lots of choices stem from your from you thinking about capital constraints of the production process, and then ultimately, as I started saying, it's process development. Like you need to understand what your process is, and how to make that process optimized for ultimate production at scale and profitable production at scale.
Got it. And so it seems that this is something that it makes complete sense, but I can imagine that it might kind of go against the culture of, how science gets started, and that it is so important to have these things in mind from the beginning. Have you had trouble like convincing scientists that they need to start thinking about this right at the beginning? Like, how are you trying to influence that culture a bit?
Yeah, I actually I think that when scientists start when they see Roebling, and when they see what Roebling can deliver, and how it can change their process and really change the way they're thinking about production, I think their eyes light up, and it hasn't been hard convincing people, or really has or really inspiring people to think differently. It's you, like the what we've delivered is it's it's a different experience of thinking about your process modeling, thinking about your capital needs, thinking about your like financial modeling that ultimately flows from your process model. And um, I mean, I really encourage scientists to take a look, because I think it can be it's a game changer. And um, when when the first like chat AI tools launched, um, people were skeptical, and now lots of for many people, it's the first point of call when they're trying to find something or answer a certain question. And what has been like 3 years.
Yeah,
Uh,
very quick.
yeah. So so I think that it it has become natural for programmers to look at how Claude Code can help. And I hope in the same way it will become natural for scientists and engineers to work on Roebling or with Roebling, uh, to um, to design their processes and um, ultimately instruct in how their factories will be built,
Well, that's great.
or
It's
instruct
not,
not to work on.
yeah. Yeah, right. And it's great that it's not taking much convincing, but it's rather just, educating and seeing what's possible. I know
Well,
you've done
it's a
a
show and tell.
yeah, as easy as that. I know you've done a lot of work partnering with government agencies. Do you feel that is it like similar that once they see something like this is possible, they're very excited about it, or do you think that government is already kind of focusing on what infrastructure is needed before funding projects, things like that?
Well, what I learned about government is that in order for the government to make a decision, there needs to be a program.
Hmm.
So first, they need to decide that they want something, and then lobby the agencies, or not. Maybe lobby is not the right word, but con convince people within agencies to allocate budgets, and there are probably people fighting for budgets. Um, Government is a massive organization, and there's no such thing as the government. It's a set of many organizations that all have their own DNA, all have their own decision making. They all have like many people who work in the government are career bureaucrats, um, and uh, um, and the I think ultimately the ethos of the government is to help move the country forward. But then there are people who were trying to move things faster, and they probably want more innovation. Then there are more conservative voices that are trying to say, well, let's not go as fast. So I think that ultimately, if there's no program for building something or for allocating capital, it will be very difficult to contract with the government. And if there's a program, then there are clearly defined pathways.
Right. It makes
You
sense that
can
yeah, something like this could open up so many different pathways and realizing ways that, their funding could go further or projects are possible that, may seem not feasible in the moment.
if yeah, and sometimes government programs start and then they end. Um,
Very true.
yeah.
Well, I wrapping things up a little, I'd love to hear your perspective on if Roebling is very successful. You have a great show and tell. Everyone is learning about this. What do you think would look very meaningfully different, like 5, 10 years from now?
I think we're seeing things being very like truly meaningfully different with AI in a matter of quarters, not even years. Uh, it's uh, it's difficult for me to predict at this point what will happen within 10 years. I think we're
Yeah.
within 10 years we're getting to singularity. If you trust Ray Kurzweil. But but I can imagine, as I said, scientists and engineers and capex managers working completely differently, thinking differently about the way they manage their R&D processes, the way they think about production at scale, the way they think about manufacturing in general, where to manufacture, what is feasible in terms of their manufacturing footprint. Um, at one point, Elon said that the factory is the product, and we hope that Roebling becomes a platform for making these products. Like you need to the factory is a product because it has features. It can be like just like any product. It can be tweaked. You can have versions of it. You get better and better at building factories, and Roebling enables that productization process. It it uses the collective intelligence and AI and subject matter experts that you can bring in to work collectively with humans and agents working together to um, design and build facilities that will ultimately produce stuff that we need. Like if we
Great.
are, if we are to get to the age of abundance, we will need to build a lot of we will need a lot of stuff, and we will need lots of energy, and we'll need to build mini factories everywhere in the world. And we hope
Definitely.
those factories will be designed with Roebling.
Great. And I love the thinking about the factories as the product themselves is an interesting way to view it. Just lastly, what advice would you give to scientists or engineers who want their work to make it into the real world but feel blocked by scale or complexity?
Oh, well, I start thinking about scale early. How does it actually scale? It's It may be easy to open one coffee shop, but building Starbucks is both art and science. Um, we see lots of small businesses flourish, and then only few actually scale. If you want your project to scale, start thinking about that scale early on. Like what is the DNA that you're trying to bring into the project, and what are the tools you can use, and ultimately, like as like one of the reasons that we really focused on Roebling is because we saw this world uh, of engineers that are and engineering projects that they're starting to dabble in AI, and there are no tools to help them.
Mm.
Uh, so we really leaned into the platform that would bring artificial intelligence and agentic thinking into the world of science and engineering to help scale. Ultimately, it's all done to help people succeed in their endeavors and do it faster, better, cheaper.
Yeah. Well, great. Well, thank you so much for the work that, you're doing to help bring really exciting scientific discoveries into the real world. I think it's such an important piece of the puzzle to be focusing on, and really glad that Roebling is doing it.
Thank you.
Yeah, and thank you so much for taking the time to join. It was really great talking.
Absolutely. Thanks a lot.
You've been listening to Accelerate Science Now. I'm your host, Adeline DeYoung. This show is produced by Kindred Subjects, Accelerate Science Now, and Seed AI. Our executive producers are Josh New and Austin Carson. Special thanks to Kevin King for editing and production. Thanks for joining us, and we'll see you next time.